this is not the unit testing. Roy couldn't make it today, so I'm your substitute teacher. But we're going to talk about how we can use best practices of other industries to help with our automation processes. So I think if you are interested in unit testing, that tells me you're probably some form of an agile or continuous shop, and this might be relevant to you as well. All right, so let's go ahead and get started. So like I was saying, over my background, one of the things that I did with the Maven project was that for a while I was running the central repository while I was at Sonatype. So I had to deal with a lot of the common download problems and things like that. For those of you that aren't aware of Maven, the central repository is the de facto repository for Maven, where all the components are downloaded by default. And I can remember years and years ago, we were not doing a lot of bandwidth, and over the years it grew exponentially, and I'll show you some of that in a minute. But when I started looking back at what we were really seeing a sea change in how software was being developed. From when I personally used to sit down and write code, we would start at void made void, and we'd write everything from the stack all the way up. And that's not really how software is developed anymore. And really the apt comparison is the Industrial Revolution, right? If you think pre-Industrial Revolution, you had craftsmiths who were building things start to finish. Take a shoemaker, right? He pounded out the leather, he tanned the leather, he cut it, stitched it, the whole 9 yards. After the Industrial Revolution, you had people who were able to specialize on certain parts of the assembly process, and in the end, the quality went up, the cost went down, and the speed to deliver these things were also improved, right? Win, win, win. And that's really what we're seeing over the past, say, 6+ years in software development. Every new package manager, every new language that comes out comes with a package manager and a repository for delivering the components. Nobody wants to sit down and rebuild the world from scratch like we used to do. So even open source back then, a lot of times it was you would download the source and compile it into your application, and nobody does that, right? We just pick up and we reuse the components. And so for those reasons, we do that for the same reasons as what happened here, right? We try to build upon the shoulders of giants. We don't need everybody in our company to be a network engineer to write a network stack or an injection container and a class path master. And those are all good things. But just like what happened with the Industrial Revolution, we have to pay attention to that supply chain of components and deal with it appropriately. And as I'll show, right now, on average, the industry is not doing that very well. And so before I go a little bit further, I just want to frame what I'm talking about here. So this is what the typical stack of an application looks like these days. And I'm mostly going to be talking about this part right in here, these components. So, it's above the operating system. These in Java, this would be jars, and NPM, these would be the NPM packages, etc. This part here at the top is the part that your developers are writing. And in the average application these days, that's usually only about 10% of the code, the total surface area of the application that you have. And this microphone's driving me crazy here. And what we've observed is that a lot of that is not being paid attention to. So a lot of tools are very focused on that top 10% that the developers are writing and pretty much ignore the bottom 90%. And so this is the chart I was talking about. Way back here, we were doing 500 million downloads in a year. Last year, we did 17 billion, and it's growing, continuing to grow exponentially. I'm not sure what the numbers we project for 2015 are yet. But month over month it's growing. And so this is evidence that more and more people are picking up components, switching to more modern development and using this. And there are statistics out there that show the NPM downloads and the number of components are even higher because they're even smaller atomic units, right? So like I said, this isn't just a Java thing, this is really an industry thing. Everybody is moving to this type of pattern. And so on one hand, we're not doing enough to be able to pay attention to the quality, the security, and the legal aspects of these components, as I'm going to show, and I'm going to use a lot of security examples of evidence, but it applies, the same basic premise applies also to quality of the components as well as the copyright and legal aspects. And so, as you'll see, it might get worse from here, and we're going to talk about that. So if we talk about the security aspect of these components, the key questions we need to understand are where are the attackers most focused, where the defender is most focused, that's us, and what activities might we do that have the most security impact. So this is from the Verizon data breach report last year, and as you can see, not really a surprise, the largest target of of attacks is through web applications these days, right? So as we do a better job of defending our infrastructure, defending our networks and things like that, attackers move to where it's easier to go after. Also, the prevalence of web applications is increasing. There's just more and more of them to protect. This is the breakdown of where we are spending our money, our security money, defending against those guys. So remember that the biggest attack vector last year was through the web applications. And so you could see here that the majority of the money is being spent at these base layers. So one might argue that the reason they're attacking the web app is because we're doing this, right? We also spend a lot of money training our people, looking at database security and things like that, but very little of the overall budget is actually focused on the actual software component of it, right? A lot of people just aren't doing it. They're not doing static analysis, dynamic analysis of the code, etc. But it actually gets worse. Of that money that's being spent, most of that money is actually spent on the 10% of the custom code, right? Those tools' missions in life is to analyze the code that your developers are producing and determine if they've made common patterns, SQL injection, things like that. And so what we have is this completely inverse scenario of where we're spending our money versus where the risk actually lies in a modern application. And so, you know, this is, if you take it the bottom up, we're building our applications on an infrastructure that we are not spending any money to defend. We're not even paying any attention to it. And when I go around the jugs and stuff like that and I talk to people, a lot of people come up to me after and they say, I have no idea that there was this much risk in my components. Right, so let me ask this while we're on the topic. How many in here are using struts as a framework? Do you know what version? Struts 1, struts 2? Struts 2? Okay. We're going to come back to that in a minute. So if you think like an attacker, though, and you analyze that shift that I was talking about from fully custom code development to reuse of components, back in the day, trying to break into a particular target was like finding a needle in a haystack. Right? That's why we spend so much time talking about common patterns, things like SQL injection, buffer overflow. It's because those were how attackers figured out how to break into an application. They knew that, you know, if I go around and check all the windows, I might find a window that's unlocked. I know what the windows look like in an application. But what's actually happened now is that we assemble our software, that shared value I was talking about before becomes our shared attack surface. It becomes essentially a common mode failure across thousands and millions of different applications out there, right? And so if you think about their return on investment, what are they going to do? Are they going to sit down and attack a single application? They might, if they really need to attack a specific bank, you know, nation state attackers. But your average attacker just looking for easy money, easy attacks are more likely going to follow the security releases that go out there. A lot of them have Metasploits that are posted with them, and then just broadcast across the internet until they find somebody. So it's basically a form of phishing, but an automated form of phishing, right? And so last year there was some vulnerabilities with struts, and it's pretty easy to go to Google and search for applications using struts. You just look for URLs that end in .do, and there's your attack vector, right? So if you've got an easy to exploit attack, and you go to Google and find out who's got a public struts application, guess what? That's the best bang for your buck if you're looking to attack applications. And so one could argue that where we're spending our money is inversely proportionate to where the risk really is, not only because the 90% of your application is built on this stuff, but this is the easiest stuff to attack. The public vulnerabilities are out there and the code is provided. So you don't even have to be often a really skilled attacker to take advantage of this stuff. And so I'm going to talk about three prevalent examples. So this one here, Bouncy Castle. Bouncy Castle is a clean room implementation of crypto algorithms for Java, right? So the JRE has different algorithms on different operating systems. They're not all consistent. So if you want to really write once, run anywhere with crypto, you're probably using Bouncy Castle. And so in 2007, there was a level 10 vulnerability in one of the core libraries. Basically, the vulnerability allowed somebody to go back and retroactively decrypt everything that was being encrypted. Right? There was no perfect forward secrecy or anything like that. And so this I use as an example of a component where people ought to have cared. It's not, somebody can't say, well, that vulnerability doesn't apply to me. I didn't fix it in my application because I'm not using that functionality. Well, if you're using something to encrypt something and somebody could completely decrypt it, you might as well not use it at all. And so since then, this is actually as of last year, but since 2007, 11,000 organizations downloaded it over 200,000 times. And they still download it today, right? If we go to the next one, HTTP client. This one had a vulnerability in it published back in 2012. It wasn't super critical, but it did allow you to have a man-in-the-middle attack. And basically, it was not checking the certificate host name that it was talking to. We saw the same vulnerability last year in iOS devices, Apple devices, and then again in Linux. It was exactly the same flaw, repeated 3 million times, almost 4 million times. It still gets downloaded, right? And this component, particularly, might be in your pocket, right? If you've got an Android device, it might be using this in one of those applications. So that's pretty important to know. And this last one is struts. And I'm going to talk a little bit more about struts. But in 2013, a vulnerability, a level 10 vulnerability was published. 179,000 downloads of that ongoing. Now this one is particularly interesting because struts is a framework. And so this exploitability, or this vulnerability, allowed somebody remotely, anonymous, without authentication, without touching a single line of your code, to basically be able to upload and then, if your system had permissions, execute code remotely, right? So think about that for a minute. Nothing that you did in that 10% of your code could have prevented this because the vulnerability was in the framework. The framework is what implements the servlet API and decodes all of the stuff, right? So this is pretty much as bad as it gets. Fortunately, most of them aren't that bad. But what we saw happen, now the struts team, I need to commend them. They did a great job of fixing the problem when it was reported, turning it around. They are very good at filing the CVEs on time, which is not always the case. A lot of times the CVEs are basically garbage. So they did a great job of doing that. They announced it in all the ways they could. And after that, we saw tons and tons of banks, government agencies, and other people go down because they were being attacked. And so what exactly happened was after the vulnerability was fixed, a release was put out, it was published, the normal process was followed, the attackers picked that up and then started attacking all these applications, right? So the struts team's pretty frustrated because they did everything right and yet people were still upset after the fact because they didn't find out about it. There is no direct line of communication between these projects and the end users like you would have in a typical commercial relationship. Also, what we saw were customers and other users scrambling to try and figure out if they were even affected, and if so, where. Am I using struts? Am I using the vulnerable version of struts? As it turns out, this vulnerability existed for something like 7 years, so pretty much all of them were vulnerable. But they had no manifest, they had no way to effectively do the equivalent of a recall. They didn't know where they were using it, and so they went to brute force methods of scanning everything on every server looking for the struts jars. So if you're using struts and you haven't upgraded it recently, you might want to take a look because it's really bad. And since then, I don't have the slide in here, but as you would expect, we see the same thing with the Heartbleed. After a public vulnerability goes out, especially a high-profile one, you get a lot of people that start looking and poking around, and then there's a whole flurry of additional vulnerabilities that are detected. That was the case with struts, that there were, every few weeks they were releasing new fixes. Fortunately, organizations like OWASP are starting to take action. They're starting to pay attention to this problem. So in 2013, the OWASP Top 10, which is sort of the list of the best practices for web application framework or web application development, added A9, which is focused on not using components with known vulnerabilities, right? Just like make sure you don't have SQL injection attacks and that stuff. Did you have a question? Oh, okay. All right, so why is this happening? Why are we seeing this trend that these vulnerabilities are out there, they're published, and nobody's fixing it, right? Why is this so hard? Well, there's a couple of reasons for that. The most basic one is obviously the way we develop software has changed, but our processes haven't changed enough to keep up with that fact. So what we effectively have with the components is a software supply chain, right? And so we talk to people, we look at the processes. A lot of people have varying levels of sophistication in their processes, and they may feel good that they have something in place, like a static analysis tool or something like that, or a review board to keep bad things out of their applications. And so we've developed some applications that allow us to understand, it's one of the products Sonatype has, but the data that comes out of this is somewhat interesting. So when we looked at the ratio of vulnerable components to unvulnerable components just in the central repository and the downloads, which in this case were 46 million downloads, we saw roughly the same proportion, 10%, of that existing in people's repositories. So it means the components are out there, available to be used, and people are still using them, roughly on the same proportion. It's not a minority of them or anything like that. And then also, when we've analyzed applications, we find, again, roughly the same proportion. So this means if you had some checks in place and you thought they were actually working, it turns out, in fact, they're not. And again, from my point of view, not that surprising, because most of the tools traditionally have been focused on the static analysis problem, the custom code problem, which not that long ago was the majority of the problem. But we've had this complete inversion over the past 6 years or so. Right, so this is evidence that what we're doing today is not effectively remediating the problem. Might make us feel good about it. There are some other problems that go along with that. The other aspect of this is that the way we approach the development of the software has also changed. Not just in terms of how we do componentization and reusing that, but how our process actually works, right? So we probably all remember this, the waterfall approach, right? And then we moved from waterfall to more of an agile development approach, which introduced, design, build, test, iteration cycles within development. And then we found that we were getting really good at creating shelfware, and it was taking a long time to get that into production. So then we started moving more towards continuous delivery, continuous deployment, which roped in operations and brought in the same tight circle, right? And so what you see here is an increasing speed of code creation to delivery. Generally a good thing. However, and also the number of cycle times went from 1 to 2 cycles per year all the way down to minutes, right? We see companies, sort of the big unicorns, right, that are doing 10,000 deployments a day of different microservices and things like that, right? So it can be literally seconds in the cycle time for those guys. Now, how do you deal with the governance in this process, right? Before, it was perfectly valid to have a manual approval process because you had probably months in your planning and designing and months in your testing to catch these types of things. But if you move all the way down here, now how do you do that? How do you get through the security and legal bottlenecks that are put in place? I assert that the security and legal bottlenecks are only there because they're still operating in this older mode up here, right? And that's what we're going to talk about. And so if you look at the typical cycle, what you have, if you imagine that for each of these things you introduced some form of governance check, you can imagine that's just not going to fly, right? Because anytime you need human review of these types of things, you just break the whole process. And so what ends up happening is that if it doesn't fit into the cycle, it doesn't get done. So we see workarounds, we see people batching these things up and waiting till the release or doing it once a week, which doesn't help for avoiding rework because, if you've got to go back and do it again, the later it takes to test it, we all know, or the later it takes to find it and fix it, we all know that costs, exponentially more. And so the reason why this is happening is because with the traditional approaches, thinking in the old way, we are forced to either go fast or be able to sleep at night knowing that we've done the best to reduce our risk. Okay. Now, on the other hand, I've just spent some time talking about data that supports that we're not doing enough to check components. There are companies who are doing some pretty decent jobs of controlling the components. The problem is they tend to be pretty burdensome, right? So the first anti-pattern we see is effectively ask someone first, whether it's a governance board or an architect or the security guy or the legal, right? So otherwise, hurry up and wait. This has been the process that was adopted in the old waterfall approach, right? It was perfectly fine to do a manual approach back then. And what this looks like is I want to use a new component. It may be a new version of a component I'm already using. I have to go and wait some undetermined period of time before I can actually get it into my repository and use it, right? Which totally breaks the Maven. Most of you guys said you were using Maven. Like, that's just insane, right? And so from a development perspective, what happens? What if I don't even know if the component I want to ask, if I'm going to go through all this red tape, what if I don't even know if it works or does what I think it does? I'm probably either just going to ignore it and not upgrade, which is why you find these people using old components, because it was just too hard to upgrade and developers just threw their hands up in the air and said, forget it, we've been using it all this time, we'll just keep doing it. Or they work around the system, which isn't really good either. And so, you know, I have some anecdotes. My favorite one is I was talking to a customer. They were using our repository manager Nexus, and they were using some of the functionality, and they made a comment, you know, we're using staging in anger. And I said, what is that? What do you mean by that exactly? And he said, well, we've got this process in place. We've automated it, so when a new component comes in that hasn't been blessed, we get notified, we check it, and we turn it around within a day, 2 days tops. That was actually pretty impressive, because most people that I talk to, it's something like 2 weeks to get approval. And so they had automated it down to a day. And what they found was that developers were actually taking jars that they wanted and putting them into the source control, because they didn't even want to wait a day to get approval, right? And then it becomes debatable whether they did it on purpose or maybe they forgot to, you know, tell somebody. It doesn't really matter. So their response was, of course, to stop people from putting jars in the source control. So what do you think the developers did next? They renamed it to something not jar, and in the build script, renamed it back to jar and jammed it into the war. And so, you know, if you stop and think about that for a minute, it's kind of laughable. Someone, whoever did that, thought that it was a better use of their time to work around the process than to stay within the process, which is evidence that the process itself was just completely busted. Right? So the organizations that were at least aware of the fact that there was some risk in these components were instituting a governance process that was probably inadvertently increasing their risk, either by causing people to not do anything and just stay on old components, or causing them to go around the process where there is no visibility about what's actually happening. Right? The other thing that we hear is some form of cut the cord, and this is sort of ludicrous. You know, we hear people say, well, let's just stop using open source. Let's go back to writing it all ourselves. We actually had a big bank tell us that, and the development team came back and said, we might as well just close the bank because we can't keep up if that's the case. We would need to, like, you know, increase our development staff by orders of magnitude to do it. It's just not going to happen. So this can't happen. And so what ultimately happens in all of these broken processes is that you end up with pointing fingers, right? The teams end up mashing the gears against each other. Development is blaming security and legal for holding up the release. Security and legal is blaming development for picking things that are broken and not caring and not paying attention to it, which is not really the case. Developers don't wake up in the morning most of the time figuring out how can I, you know, hose my project or my company, unless maybe they're in office space. But you know, the same thing with security. They're not trying to stop progress. They're trying to reduce the risk. But like I said before, the old approaches are focused in a way that make you have to have a decision between either I'm going to do something about this or I'm going to go fast and hope that I don't get caught. And so to summarize the problem, component usage has exploded, mostly for good reasons. Applications for the security side are the primary vector of attack. There's a lot of components that are out there. There's something like 1 million components in Maven Central alone, and that's just one repository. And specifically, the current approaches can't handle the complexity at speed. They just can't do it. They weren't designed to solve that problem. But fortunately, it is possible to address speed and quality at the same time, and we are not the first industry to face this challenge. We only need to look to other industries who have solved this problem in the past. Now, with various degrees of success, but mostly pretty good, right? So of these pictures here, we have the Chevy Cobalt, the Boeing 777, and food, right? We always know about the food outbreaks, and ultimately they can usually trace them back to where the food came from, right? Lot numbers and things like that. The Chevy Cobalt one is an interesting use case from my perspective with my background in Maven. I don't know how many of you know about this, but this was an issue where there was a problem with the ignition switch, where the keys would cause it to basically shut off the car while it was driving. When the car shut off, the airbags went off, and unfortunately some people died. The interesting aspect of this part of the story is the problem was known at some point in the past and even fixed. but they didn't rev the version of the fixed ignition system switch. So at the end of the day, it was sort of like in Maven, just re-releasing the jar again to fix the bug. And then now you have no way of knowing what version is in which car. And that's what happened. They ended up having to recall most of them because they couldn't figure out who got what component, right? So this was extraordinary because it failed in the basic tracking of components. When we think about cars, we think about airplanes when they had the problem with the batteries a few years ago. They were able to trace it down to the exact lot from the battery manufacturer that caused the problems, and I think it was 3 different airplanes. And that's because they did a great job of knowing where their components came from and which specific planes and cars they went into. We don't even do that with our software that controls the cars, keeps the planes from crashing into each other in the air, keeps our financial markets running, right? Most of the people are just downloading components from the internet, sticking them into their application, saying it works, it's good. I have no idea who actually built it. I didn't check the signature. We know that from data on Central because we require PGP signatures of everything that goes into Central. And it's like a 0.01% of the downloads are actually PGP signatures. Nobody downloads them to check them, right? And so we're not taking the same level of due care that these other industries have. And so the common pattern here is that all industries with the ability to do harm have ultimately either on their own or have been forced into thinking about their supply chain and doing something proactive against it. And if you think about where we are today with the Internet of Things, we have devices that go in our bodies in terms of insulin pumps, things like that. The stuff that keeps our doors locked and whatnot, right? Our financial markets, high frequency trading algorithms that go bad and cost people millions of dollars. We're not taking that same level of due care. And I think we really need to think about that. Now, if we take a look at the Toyota supply chain management, I think we can learn some stuff there. So I'll let you take a look at those numbers for a minute. So the main point here is that we all know that the Prius is obviously the more popular of the two. But I find it somewhat shocking that they have only 125 suppliers for the typical plant versus Chevy having 800. Across the whole company, they have 224 different suppliers versus 5,500. And yet, even though they have that much fewer suppliers, they only have to build 27% of the raw components in their car. So they're exponentially using more advantage of a better supply chain, right? Now, one could argue that this has a pretty marked effect on both the price of the car and the reliability and the popularity. It's not by accident that they work so hard to keep this down. And so the reason is that they follow these sort of things. Whenever they evaluate the impact of some change, whether it's to introduce a new combination of colors, let's say, or a new seat or a new transmission, they think about, does the variety, am I being driven to have more variety because I need to respond to market pressures? That's almost always the case that causes us to do anything, even in software. But before they make a decision based only on that, they think about what is the impact to these other pieces, right? And if we think about that in software terms, it's exactly the same. If we choose to pick up a new UI framework, we should think about what the impact of that will be to the velocity in the future of our ability to deliver software. Does it help it or harm it? Does it get in the way of me moving developers around from one project to another? That can impact the variability, right? So if we're trying to be more continuous, we're trying to constantly improve our processes to stamp out the bugs and improve them. It's all about these same things that we do. And so in software development, we're ultimately trying to do the same things. We're just not thinking about the problem the same way. And I think if we reframe the way we think and we look at how these other industries work, it will help us figure it out. And so at Toyota, every time, these are sort of their main theories of how they evaluate what they're doing. And so the previous slide was about showing how they evaluate a particular decision, but these things here override all of them, right? So for any particular thing, they're trying to create awareness, empower, govern, and monitor. So let's dive into that, and then I'll talk about how that applies to what we're trying to do in software development. So the first part, create awareness. Unless the problems are seen, they're not going to be solved, right? That's fairly obvious. So how do we do this in software development today? Well, the first part is it needs to be fast so that we can be continuous. Even if we're not trying to be continuous as an organization, it's still important to be fast, to think about the future so that you can go faster, right? So it means that the analysis that you need to do of these components, of the decisions, have to be able to be done fast. It needs to be happening every single build. It needs to happen every time a developer is looking at a new component. It's not sufficient to wait days or even hours for those results. The way you do that is to focus on the attributes of the components. So focus on defining your policy in the terms of what does a bad component look like? Well, for a particular application, a bad component might look like it has a copyleft license. Can't use it for something I'm distributing, right? In a different application, maybe that copyleft is okay because I'm just building services. An attribute might be it has a known security vulnerability greater than some number. Or maybe it's old or it's unpopular, right? This is a different take on how people tend to manage the components today. Like I talked about before, the default approach was to ask somebody for a particular version, right? And so somewhere, someone has a list of these attributes that they're using to evaluate it. If I go ask Bob, can I use this component? He probably has a list. So all we're saying is take that list and put it in a form that the machine can automate because it's the only way to keep up. So you allow the humans to define the policy and allow the machines to do the automation, and then the humans only have to deal with sort of the gray area, the maybe approvals. So even if you still need to have some form of approval process in the end, which is the case in some industries, some companies, you could still use the automation to sweep the automatic approvals and the automatic denials away so that you don't need as many people answering every single request for every component. They only can answer the ones in the middle. The data, because we're trying to drive awareness, needs to be easy to consume. Nobody wants to deal with a giant spreadsheet to figure out what's going on, right? So the user experience of this aspect needs to be front and center so that people can at a glance figure out what's going on, all the way from development up to upper management. Now, we need to empower the developers. When we talk to security and legal, a lot of times they talk down to developers. They talk about the fact that they don't want to make it better. They just pick anything they want. It's not entirely true, but what's happened is that developers are often incented to go faster, deliver new features. There's nobody checking the quality of the components going in. It's basically not something you measure, right? So you get what you measure. And so what we see, again, that sort of Boolean choice, people feel it's too hard to measure, so they don't bother. And so we want to empower developers. Well, if you follow those two previous suggestions, it's already fast and automated, but now everybody can be on the same page. So we don't play this game of, well, I'm about to cut a release, but now security is finally looking at it and finding out that I used something wrong. Or architecture looks at it and says, I can't use struts because we've banned struts or what have you. And by having this up front, the developers can just make the right decisions from day one. Right? So you're empowering them to do it. You're also empowering them to improve the process themselves and improve the product themselves. So like I talked before, some of the procedures that have been put in place actually incent developers to do nothing because it's too hard. Well, imagine if the developer was looking at all versions of a component and could see that the one they're using is vulnerable, but a minor dot release forward fixes the problem, takes it from a red to a blue, right? That's pretty easy. You don't find that in typical approvals because you're never going to find out unless you go ask the guy, and he might say no anyway. And his answer might be somewhat arbitrary. So being able to do that has a lot of benefits and really reduces the finger pointing, at least until when it's really justified. You know, if development has this at their fingertips and they ignore it for 6 months and then they pretend to be shocked when they cut a release, well, that's their own fault, right? But at least the system was set up to incent the right behavior. The data that comes back from it really needs to be precise. And this one, I use struts as an example here. These numbers are a little bit old. But what we saw, because the manual approval process was so burdensome, what we saw people doing is they wouldn't even go down to approving a specific version of a component. They would just say, yes, you can use that technology. Yes, struts is okay. So somebody did a check at some point in the past and decided it was okay. But as we talked about before, any version prior to 2.3.16.1 was completely ownable and completely get your system attacked, right? So there's a world of difference between just saying, yeah, you can use struts, or no, you must use this version or greater, right? And so the only way you can do that again is through automation, like I talked about. You can't do this in a manual approach. The other aspect about the precision is you need to be precise in the data that you're giving to people. So this was one scan that a customer told us about. they found 50,313 potential issues in the source code. I think this was a legal scan. The real issue count that actually warranted further investigation was only 200, right? So they had one of their best engineers spending months and months just wading through basically piles of paper for false positives. So you can bet the next time that they need to do an approach like this, they're not going to do it because it just looks too hard. The results need to be contextual, and I hinted at this before, but really the policy can't be a one-size-fits-all. Because what happens is if you tell your entire development organization you can't use anything that's copyleft, even if you're developing internal applications or services, or if you use the same security policy for everything, even if it's like just some internal calendar app that maybe isn't exposed, what tends to happen is developers look at that and they don't have buy-in to the policy, because what you start to look at it and you say, I know that doesn't apply to my application. And then it starts a slippery slope of thinking to, well, none of these apply to me, I don't have to pay attention to them. And so you need a way to be able to define the policy so that you can clarify the attributes of the applications and associate the policy to that, right? So you might have a stricter set of security obligations for anything dealing with credit card data because of PCI spec. And so you want to be able to say which of my applications have credit card data and the policies are stricter for those, just like you would do for services versus distributed application. And this is really important. We have to think about developer buy-in on this whole thing because developers don't want to be governed. They want the data to be empowering to them, but if it's misused, they lose the buy-in because they just think it's not applicable to me. The data provided needs to be actionable. So it's not sufficient to just throw something up and say, you got it wrong, go back and pick another component, right? You need to be able to tell me what to do. And the worst problem, this is really bad in security because the average developer is not a security expert. They may not know what a Blinkenbacher attack is. I didn't until I went and looked it up. And so what happens is if you just provide data to the developers about here's all the problems with your component, the first thing that they want to do is rationalize, do I actually have to take an action on this? Does it actually even apply to me? That goes back to the context awareness part. But they may be trying to look at the security aspect and justify, well, I don't use that class, or I don't pass data to that. And maybe that's the case today, but will it be the case tomorrow, 6 months, or a year from now if they don't update it? And so by providing the data like the example I gave before, where all you have to do is move to the next minor point revision, which is probably API compatible because it only fixed the bug, that becomes the easier thing to do. So you want to set up the data, set up the results in a way that makes the easy thing the right thing to do, not the wrong thing. And that, if I were to sum up the other governance processes that I typically see, it's exactly the opposite. Now, this part is important because even though we've done the data, we've made awareness, and we've empowered people to fix it, sometimes you still need a little bit of a stick approach to get people to start paying attention. And so you need a way to ensure that people stay within the boundaries that you've defined for them. And so you need to be able to govern this in a multiple different ways, but specifically you need to govern it across the life cycle. It's not sufficient only to do a scan at release time, because all that time and energy has been put into getting a release candidate ready only to find out that there's a policy violation, security, copyright, whatever. And so you need to be able to think about this process all the way across the life cycle so that you effectively look like this. And if you remember the old process, if you were to insert manual, this was days at each one of these things. But if you automate it in a way that it can be done in seconds, it no longer has that trade-off. And so you can now actually go fast and sleep at night. You're not forced to make this decision of how deep do I look, right? And so you get all the obvious benefits here about doing so. And the next part of this is pretty important, which goes to the title of the talk. The ability to do the governance in an automated way is ultimately the only thing that clears the roadblocks. Until you can demonstrate to the security and legal professionals in your organization that we have a way to not only drive awareness and development, empower the developers to fix it, but most importantly, ensure that it gets fixed, until you can do that, they're not going to give up that demand to want to do manual approval every single time. And so you need to be able to get all of this wrapped up. That's really the important part of this. And you need to be able to monitor both your improvement of the process, right? So you need to be able to monitor what's going on. When we put out these violations of the policy, how long does it take for development to fix it? Are they ignoring it for a long time? Maybe the policy's not right. Are there policies that are being waived all the time? Maybe the policy's not right, right? So just like Toyota, they're continuously trying to improve their process from the bottom up in a Kanban type process. We want to be able to think about the same thing with our governance. And that often means not just doing a DevOpsy thing, but it's more like a DevSecOps, legal. You know, you bring everybody together and review the policy, try to understand the common goals, and figure out a way that works for everybody. This one is really important. I hinted on it before, but through this process, you need to be able to build up a bill of materials and a manifest of all of those components you're using and where. So when the inevitable happens, you know how to respond. If you need to respond and where you do. Just like the struts example I gave before, that people were just like virus scanning their applications, all their ops servers trying to figure out where the heck this thing might exist. And I think this is a very similar approach to what we talk about in Agile. We talk about in Agile, it's all about change management, right? The manifesto says we recognize that change will happen, and we strive to make change as painless as possible. Well, we need to think about the security and these other things the same way. New vulnerabilities will happen. Humans are writing the code. These things are out there. The attackers, like I said before, are paying more and more attention to them because it's the easiest thing. The ROI is the highest. And fundamentally, none of those behaviors are going to change. So there will be these new violations. And so we need to set up our system in a way that recognizes that will happen and make it easy to respond. It's just that simple. It seems very obvious, but it seems across the industry we don't do that. And lastly, we also need to be able to monitor the applications over time, because applications are not like wine. They don't age. They rot like milk. Right? So if you put an application out there today and then you don't touch it for years, it's probably not getting better. The information known about those components that make up that application are growing over time. There may be a bigger and bigger pool of known vulnerabilities against that thing. So at the time you release your struts application, hopefully it was known to be good. But if you just let it sit for 5 years, there's probably 15 or 20 different known vulnerabilities against it, and you might be getting attacked. Right? So you need a process that can use that bill of materials that I talked about in the past slide and be able to continuously monitor all of those components for changes in their state. And that goes back to being able to define your policy in terms of the attributes. Because while the component doesn't change, what we know about it does change. And those manual approval processes typically work by saying, yes, you can use this version, so I'm going to put it in this bucket over here, and that defines it. The fact that it's in this bucket over here is the only attribute that defines it as being good. And so once it's approved, it's always assumed to be golden. And that's usually the reason why we see people continue to use broken components forever and ever. And that's the whole thing. Questions, discussion?
What are some of the tools that can be used for continuous governance?
That's a great question. Obviously, Sonatype has some. You can come talk to us at the table. We see a lot of people that are using various other tools, and so it's not a case of either or. It's not a case of should I do static analysis or should I do component analysis? It's really about both, and it's about how you apply that process. If you're instead sitting there saying we're only going to send our stuff off to static analysis once every 6 weeks, it doesn't meet all the traits that I talked about, right? So there are a lot of tools that can do it in a homegrown fashion. Not a lot of people are focused on automating the policy for the component aspect like we are. That's why we're trying to get the word out there. You had a question?
It seems like there's not the incentives, let's say, there's a lot of tools for the code that we write, to optimize and look for vulnerabilities, best practices, and all of that. And there's a good market for that. I think that's why things are being developed for that space. But for the components, if somebody finds a vulnerability, there's not a financial or there's not much of an incentive. It's in everyone's interest, but there's not.
There is, and I think. Yeah, I'm going to repeat it. So the the question was, is there an incentive, or are the incentives aligned for component analysis versus, like, say, static, for example? I think they are. I think the problem is there's just not enough general awareness of the fact that the way we develop software has changed. If you talk to any developer who's actively coding, of course they know that. But if you talk to someone who's a manager, maybe coded 10 years ago, they may not be acutely aware of the problem and how it's changed, right? And so when they're thinking about how do I approach the security, they're thinking about what they know and not how it's changed too. That's my personal feeling on why that's misaligned, because usually when I go and I talk to people, they get it right away, and they come up and they say, I never thought about it, right? I never thought that was the aspect of how this goes. So I think ultimately the incentives are aligned. People will figure it out. If you look at shell shock, Heartbleed, those were component-based attacks ultimately. I mean, SSL is a component of an application. It's not a jar, but it's still critical to the functioning. That wasn't code that they wrote, right? So those types of things are helping to drive awareness further up in the organizations.
Who found those vulnerabilities?
Who found those vulnerabilities? I probably knew this and I forgot, but I think the SSL one was security researchers. I'm not sure. The network engineers. Yeah, and they broadcasted it. They found the right approach, right? They did the team, just like the Struts one. I think the Struts one was reported by a bank in Japan, I think. The Struts team did their thing, but then once it became public, then all the other banks got attacked, right? So it almost doesn't matter who finds it, because the de facto process is to make everybody in the world aware so that they can fix it. It's just unfortunate, but the attackers are the ones paying attention, and it's easier for the attackers to pick up the exploit and go attack an application than it is for most companies to swap out a framework and get it released on the same day. It's just not going to happen.
You know, if at like the repository level for things like Maven, they're interested in versions and names and things like that. Would there be any move to include things like vulnerability right in the repository, so that as part of the metadata?
There is. That's part of what we try to do. We try to put a product around that. The information is out there and available. But trying to associate it to the specific components that are affected is a pretty big task. And so there aren't a lot of open source projects that are doing that right now. And the tools aren't set up to be able to consume that information either. Because even if Maven was pulling it down, it may not help, because that's probably only going to alert you in the build phase. It's not going to help you detect things after the fact, right? So an ecosystem around that may evolve at some point. It's just not there right now. Any other questions? All right, well, thank you for attending. Hopefully it was as good as the unit test talk you thought you were going to hear.